let's look at this idea of areas in a bit more detail. Because one of the things I said yesterday was, if it's above the axis, then we know the answer is positive. If it's below the axis, then we know the answer is negative. Now, that's fine when we're just calculating an integral. But when we're talking about an area, that creates problems. Because how do you deal with negative area? So our first situation here, we've got, if I'm going from A to B, that's above. That's fine. So that area will be positive. I'll integrate. I'll get the answer for that area. So there's area 1. It'll be the integral from A to B of function x. If I go from B to C, the answer to the integral will be negative. We don't have negative areas. So area 2 would be the negative of that answer. Because I know the answer is going to be negative. So negative times a negative will give me a positive. I'll get the actual area itself. So this is where we've got to be careful. Because if we've got an area below, we know we've actually got to subtract the integral rather than add the integral. So anytime you've got an area below the x-axis, it'll be minus the integral from B to C. Well, another way you could do that is you could simply say, what's the absolute value of the integral? Because then it would become positive. A lot of people do it that way. Personally, I think it's easier to do it this way. Swap the limits. So we said if we swap the limits, it changes the sign. So then I'm always dealing with positives. If it's below, instead of going B to C, I'll go C to B. And then I'll get a positive amount for that area. It has other advantages too, which we'll see in our examples. Let's start with y equals x cubed, our basic cubic here, which is symmetric, but I've got a bit that's below and a bit that's above. So the bit that's below I know is going to be negative. So I'm saying it's negative, that integral from minus 1 to 0 of x cubed, but then it'll be plus 0 to 1. Of course, the actual integration is going to be the same for both integrals. So add 1 to the power over the power, we get a quarter of x to the power of 4. Substitute the top minus substitute the bottom, we come up with a half unit squared. This sort of question, though, there's better ways of doing it. Because I can notice the symmetry. Remember that symmetry is going from minus 1 to 1? This is why we don't use the integral. What did we see yesterday? We said if you had an odd function and you integrate from minus 1 to 1, the answer will be 0. This is why it's equal to 0. Because the area below is negative, the area above is positive. Add them together, you get 0. That's why we have to be very careful. Are we finding the answer to the integral or are we finding the area? If it's the integral, then the answer is 0. But if it's find the area, then it's not 0. Well, clearly it's not. We see it's got area. But if it is area, I can use the symmetry and say, well, because it's an odd function, I know those areas are going to be equal in value, so I'll just go twice 0 to 1. Similar as what I would do for an even function. And then that works, and we get our half. This one, though, there is still symmetry on this one, by the way. It's just around negative 1 rather than the origin. But let's not muck around with that. I've got two integrals. The first one's above, so I'm going from minus 2 to 1. The second one's below, so I'm going from minus 1 to 0, but it's the negative of that. This is one where I'm going to swap the limits for a very good reason, which we'll see in a sec. So notice I've made it plus, but I've swapped the limits. Why do I do that? Because I've got less to substitute in now, because what I can now say is it's twice the top. So the top's the same in both. So for both of these, I would have substituted negative 1. So I'm going to do that twice. And then I'll subtract the bottom ones. So I'm going to subtract negative 2 and I'm going to subtract 0. Yeah, okay, it's one less substitution to do, but it's one less substitution. Swap the limits, makes it a little bit more efficient. By a coincidence, it's a half unit squared. I don't want you thinking every answer is a half, okay? It doesn't always work out to be a half. What about if instead of going to the x-axis, we want to go to the y-axis? Well, it's exactly the same, but now we're doing things with respect to y instead of with respect to x. So how do you remember that? Very easy. Because if my area is going to the y-axis, then it's the y. Whereas if it's going to the x-axis, then it's dx. I'm going to have to then make sure everything's in terms of y. So x is going to be the subject. Then it's the y coordinates I'm going to substitute in, not the x, because everything's with respect to y. And it will become the integral from c to d, the y values, of our function in terms of y. So everything's with respect to y if I'm going to the y-axis. So let's do this as an example. Y equals x to the power of 4. It's that green section that I want to find. So the y values for this, hang on, I haven't got them, have I? I've only got x values. So we're going to have to work out the y values. I've rearranged the equation. I've made x the subject, so it's y to the power of a quarter that I'm going to be integrating. 1 and 16 would be the corresponding y values. Add 1 to the power over the power. So essentially it's exactly the same, but now it's just in terms of y instead of terms of x, but we get the value for the area. Well, what happens if we're not actually going to an axis, but we're finding an area that's trapped between two curves? So here's a random curve, y equals function x, and I've got another curve, y equals g of x, but I'm interested in how much have we trapped in between these two curves. I'm going to have to find the point of intersection, because where do I start, where do I finish? But notice by drawing in those dotted lines there, it now kind of makes it obvious what I've got to do. All I've got to do is find the area under the red curve going to the x-axis and subtract from that the area under the blue curve. That will leave me with what's left. Okay, so it'll be the area under the first curve minus the area under the second curve. I've got the two integrals, they're both going from a to b, the limits are the same, so I can combine that into one integral. So I simply do that subtraction. The top function minus the bottom function, whichever one's on top minus whichever one's on bottom, that's what I've got to integrate. So it's very useful to know which one's on top and which one's on bottom. Because if you get it the wrong way around, you get the negative of the answer that you're actually looking for. How do you get around that? Some people just make clever use of absolute value symbols, because they'll do their answer and go, oh, negative. Oh, I know what I'll do. Absolute value, absolute value, absolute value, absolute. Oh, look, I got the answer. If you do that, you want to make damn sure that it is negative and you haven't made a mistake somewhere. Let's try this one. X to the power of 5 and y equals x in the positive quadrants. So let's draw it. There's y equals x. There's a very dodgy looking y equals x to the power of 5. I want the area between these two curves. So it'll be top minus the bottom. X is the one that's on top here. Point of intersection, well, it's got to be x equals 1, doesn't it? But if you're unsure, just solve them simultaneously. So x to the 5 equals x, sure enough. Well, there's actually 3 points of intersection. I'm only interested in the 0, so the origin, and x equals 1. They're the two I'm interested in for this problem. And it'll be the top one minus the bottom one. There we go, 1/3. Now, this brings up the problem of, well, what about if some's below and some's above? Not an issue. We don't have to worry about that when we're trapping it between two curves. So that brings me to this HSC question. It was a 2-unit question, so they kind of explain everything for us, but the graphs y equals x minus 4 is drawn, but so is x squared minus 4x, and they've told us it intersects at the point 4, 0, and I think I've left out the word and there, and the point A. First part of the question was, what's A? 2 marks. Ooh, generous. Well, solve them simultaneously. Quadratic to solve. Look, x equals 1 or x equals 4, but we already know about the 4. Therefore, A must be the other one, so it's 1, negative 3. Okay. Find the area of the shaded region, there it is there, bounded by y equals x squared minus 4x and y equals x minus 4. Okay, top one minus the bottom one. That's what we said we'll do. Top one minus the bottom one, the line is on top. So I've got to integrate minus x squared plus 5x minus 4. So add 1 to the power over the power, substitute in, and we have our answer, 9/2. And then there was this one in 2005. Have a look at this. We're inside a circle and a parabola, shaded region that defines it all for us. But they've given us a hint. By considering the difference of two areas. Oh, well, that's what I would have done. Top one minus the bottom one. Difference of two areas. Find the area of the shaded region. But look, we have to be very careful here because the boundaries change. If you go from left to right, we start off. The top one is the circle, the bottom one is the parabola. And that's beautiful until we get to x equals 1. After that point, boundaries have changed. The top one's still the circle, but the bottom one is no longer the parabola. It's now the x-axis. So we have to split it into 2 areas. So I think that's what their hint's getting at. So, all right, let's put a line there. There's the 2 regions I'm going to find. So the area between the circle and the parabola, but also the area between the circle and the x-axis. Add those two together, we should get the answer. However, there's a smarter way of doing it. Sure, I could have done it that way, but let's look at this picture a different way. How about I subtract the area under the parabola from the quadrant of the circle? If I just take that out, I'm going to have the area that I want. Why is that better? Because we got a formula that will find the area of a circle. I don't have to use integration. So I can say it's a quarter the area of the circle, pi r squared, minus, and then I've just got a straight integral from 0 to 1 of the parabola. Okay, still got some integration to do, but just 1, substitute in, there's my answer, pi minus 5/6. Have I satisfied the actual question? What did it say? It said, by considering the difference of two areas, what did I do? Yeah, I did that. I considered two areas. Might not have been the two areas they were expecting, but I've still done two areas. I've done what they wanted and come up with, I think, a better way of doing it. Okay, 5F and 5G.